Hello, ladies and gentlemen. Welcome back to Chapter 12. We are talking about solutions, and today is Part 6. Today we are going to be talking about something called colligative properties. Now, these, although the definition looks a little confusing, are not horribly confusing. Reading the definition, colligative properties are the properties of solutions which depend on the ratio of the number of the solute particles to the number of the solvent molecules. Okay, so basically you just have to look at how many particles versus how many molecules. Okay, it's not horribly different. Now, the big thing with this is if you have a substance that comes apart, in other words, an ionic substance, it counts, the number of particles counts as however many pieces there are. So, for example, salt, sodium chloride, becomes ions of sodium and ions of chloride. That means that for every one salt that you put in, you have two particles for every water. Okay, something like sugar, when you put it in, remember covalent substances don't come apart for the most part. So every sugar molecule you put in would only count once. Now, the thing is, it does not matter what the solute is, what you're dissolving in. It only depends on what the number of the particles is as to how these properties act in a specific solvent. Okay, so the first colligative property we're going to talk about is vapor pressure depression. Hard saying that fast. Vapor pressure depression. Now, depression simply means that something decreases. So this is the pressure of the vapor is going to decrease. Now, if you look at the pictures, if you just have a solvent, for example, water, the pressure above it will actually be higher than if you have something like salt water or sugar water. Because what happens is evaporating particles kind of get, they have to go fast enough to leave the liquid. Well, these particles, they'll be traveling and they'll hit part of the solute, and that will stop them and slow them down. So they won't get enough momentum going to evaporate as quickly. Okay? It says the presence of a non-volatile solute means fewer solvent particles are at the surface, so less evaporates. Volatile just means that it evaporates easily. Okay, so if you have something that evaporates easily, but you dissolve something into it, it will slow down how easily it can evaporate. Okay? Just because those solute particles get in the way as the liquid, the solvent, is trying to go fast enough to escape the liquid and become a gas. Okay, next we are going to be talking about boiling point elevation. Elevation, of course, means going up. So the idea being that it's going to be harder to boil something if you put a solute in. Now, this is a direct relationship back to what we talked about of the vapor pressure. If you have a substance that you've added a solute to, it has a lower vapor pressure. Now, bubbles can't form when you're heating something up because the vapor pressure is low. Okay, so what ends up happening is you have to make it hotter and hotter and hotter in order to increase the pressure so that it's the same as the atmosphere. So if you put salt or something into water, it will be a higher temperature when it starts to boil. That is why oftentimes people put salt into the water when they're going to cook pasta. It makes the pasta cook faster because the boiling water will actually be hotter. Okay? Uh, so that is a very useful thing, is to have a boiling point elevation. It makes it hotter in order to boil it because it's hard to boil. For the same reason, the solute gets in the way. You know, this is just really a lot of evaporation happening quickly. So if you have those solutes there, it slows the solvent, the water, whatever it slows it down by getting in the way. And they aren't able to evaporate or boil easily. Now, next is freezing point depression. Remember, depression simply means decrease. So this is kind of the same reasoning, but reverse direction. Okay, if you have this solute dissolved in the water or whatever solvent it is, they get in the way when it's trying to form a solid. Okay, you know, water turning into ice, all of these things are in the way. So it has to try to get everything out of the way in order to form ice. This is how ice cream is made. It is simply reducing the amount of the temperature by adding salt to the ice in order to make the cream cold enough that it freezes. It is the same reason why people add salt to the roads when it's snowing, so that the freezing point is colder and then all the snow will melt. Okay, because normally it melts at 32. Salt will continue to melt the snow down until it's about 10 degrees. So that's very cold if you've never experienced it. Okay, so freezing point depression, the solutes are getting in the way as it's trying to form crystals. Now, the last thing we're going to talk about is osmotic pressure. Now, hopefully you remember what osmosis is. It's where things are going from a high to low concentration of water. Okay, this scenario setup is basically you have just a tube, and in the middle you have a membrane where the water can go through, but in this case, sugar cannot. Now, water will try to balance out the amount of water on each side. It goes from high to low concentration. So the water is going to go from pure water over to the other side to try to balance it. And what you see is eventually you end up with one side having a lot of extra volume because it's trying to balance out the amount of water by osmosis. Now, the reason this is important is because lots of times when especially we're dealing with living things, we need to have what is called an isotonic solution. That means you have to have the same amount of solute inside and outside. That way you don't, destroy and kill the cells. If you have more solute, you could end up with having the cells shrink. If you have less solute, your cells could actually explode. So, believe it or not, chemistry is important when it comes especially to medical things. If you ever read your saline solution for your contacts or something, it will say it's a buffered isotonic solution. If it was not isotonic, it would hurt your eyes, even though it's just the same materials. Okay? Because it would change where the water inside and outside of your cells was. Okay? So this is the different types of responses, the properties created by having a solute added to a solvent. It changes how that solvent is going to act. And remember, it does not matter what kind of solute, it matters on how many particles of the solute compared to the solvent. Okay, until next time.